to get to this particular location, we have to rely on helicopters, and that's because the safe areas to work in, they're quite limited. So where we're currently standing, it's a solid block of ice. It's safe to be here, but to move outside that area is not safe. So we have a limited area that only helicopters can land in. But then to get the helicopters from a ship, you have to get quite close to the glacier, and that's when sea ice can come into play. If the ice is too thick in the ocean, you can't get your ship close enough. So basically, there has to be this alignment of factors. You need good weather, you need good sea ice conditions, and then you also need to find a safe place to land. So we've fortunately been able to bring that all together, which is why we're standing here today. Thwaites is a river of ice. It's the size of Great Britain. It's located in West Antarctica, and it's slowly flowing off the continent into the ocean. Thwaites as a glacier is really important in West Antarctica. It's kind of like a keystone glacier. We kind of understand from our modeling that if we lose Thwaites, if Thwaites were to collapse entirely, it might destabilize the rest of the region. We're here to fundamentally understand how quickly the floating part of Thwaites Glacier is melting. So in front of the glacier, there's the floating portion, and that acts like a dam, holding back the ice that's on the land, so it slows down sea level rise. But we know it's melting from beneath, and we want to understand why it's melting and how quickly it's melting and what's driving that melting. So the instruments will deploy through the borehole. They'll measure the ocean temperature, the ocean salinity, how quickly it's moving. And from all of that information, we'll be able to kind of reconstruct a picture of what drives this rapid melting that we see, and try and understand why that's causing the glacier to disintegrate.